Okay, so hey guys, welcome back to my channel. So this is a new channel basically, IIT JAM and GATE chemistry के preparation के लिए. So my introduction, I am Rakesh Samantare. I am a MSc chemistry pass out from IIT Delhi, and thereafter I did my MTech in material science and engineering through GATE chemistry from IIT Kharagpur. So I'm here to, cover some of the questions, some of the quality questions which are usually asked in your IIT JAM and GATE examinations. Since your exams are very near, so I basically thought to, you know, contribute something to your examination preparation. So that's why I'm going to start a small question series here, जिसमें I'll be covering some basic questions, basic to advanced level for IIT JAM as well as GATE chemistry. Okay, so uh, content, I guess each and every one of you know that content is available in surplus level in the internet, but question practice is what is really required right now. So I'll be starting with question practice and धीरे धीरे simultaneously I'll be coming towards the content part. So let us start. शुरू करते हैं. So you see, this is a question, typical classic question of organic chemistry. It was asked in JAM 2025, that was conducted by IIT Delhi. So we'll begin with this. You see, they have asked the two major products, P and Q, of the following transformation. In both cases, the base is provided, only the stereochemistry differs. So, okay, let us start with this. Okay, so I'll check whether everything is working or not and let us copy it. So basically, what they have asked in the first one is they are having basically this. One second. Okay, bromine above, CO2H also above. Okay, so what they are having is basically this thing is in above position. Okay, the bromine is in above position and this is also in above position, right? Just pardon me, I'm a bit slow on the pen tab because I'm just new to this setup. Previously, I used to teach using a chalk and a board system. So I hope all of you will cooperate. So this is CO2H, and basically here is your methyl groups, and this is also the above stereochemistry. So if you look at this particular stereochemistry, okay. So if you are looking at this particular stereochemistry, so if you convert it to the like chair conformation, so what you get is basically you see this particular bromine, it is in the axial position. Okay, this particular bromine is in the axial position, and this particular COH, it is also in the like above the plane position. Okay, and here the proton is in the anti-parallel or anti-axial direction to the bromine group. And here we have the bulkier alkyl chain. So I'll put it like this. Okay. This is the configuration in which uh, the alkyl group or this bulky group exists. Okay. So this is what is provided to me in the question. So when you are using a base, let's suppose you are using any particular base. This particular base, that in E2 eliminations, basically it's a classic case of what E2 elimination reactions. So you know that in E2 eliminations, there is anti-parallel, elimination and the leaving group gets knocked out. So basically this base is going to abstract this proton, this thing is going to go here, and this thing is going to leave easily. Okay, so this is what is going to happen, and you will be getting this kind of product, okay, where basically you have this and you are having this, and you basically get the double bond somewhere around here, okay. So you get the double bond here, and you have the CO2H group here, right? Okay. So if you match the options, you see, let us see. So this is basically for the product P. This is your product P. And if you look at this product P, if you look at the options, you can easily eliminate this thing. You can easily eliminate this thing. Okay. B gets eliminated, and A also gets eliminated because we know this is not our product P. C and D are remaining. So the rest can be easily found out through the product Q. So let's go to the next part, that is the product Q. So if you look at the product Q there, so this is the product Q, they have changed the stereochemistry. So here's an interesting part here, okay? So now I'm going to erase this, okay? Let's delete this, okay? Okay, so now we'll come to the product Q. So now what they are asking is the product Q, basically the bromine is in the above position, same position as before. The bromine is in the same position as before. This thing is also in the same position as before. The only change is now CO2H or the carboxylic acid groups lies below the plane. So same thing, you can convert this into the typical, chair conformation thing. So you can say that your bromine is, above, sitting above. I'm sorry. Wait a minute. Okay. So you can say that your bromine is sitting above, and basically this carboxylic acid, which was initially above the plane, is now sitting below the plane. Is now sitting below the plane, and this hydrogen or this proton is now here. Okay. So as you can clearly see, there is one particular change here, that now in the anti-parallel position, the carboxylic acid groups lies instead of the proton. So when you provide a base, or when the base comes, so what happens here is, basically we know carboxylic acid proton is a highly acidic proton. This proton is highly acidic. You know that. I think we all know that. It's a highly acidic proton. So what would happen is, basically this base, now since the hydrogen or the proton is directly not substituted antiparallel to the bromine group, and since this has significantly greater acidity as well, both the factors favor the abstraction of this particular proton. So what happens is, this particular proton gets protonated, you get actually a CO2 minus group, and this bond actually shifts here, and this bond actually shifts here, and this bond goes here, and this bromine gets knocked out. So you see, uh, the byproduct here is basically carbon dioxide. So typically it's a base catalyzed decarboxylation reaction that's taking place here. So here the product that you get is basically the final product. The final product looks something like this, okay, because both the carboxylic acid and the bromine have been knocked out. So here you get something like this, okay, which is your product Q, right? So if you look at the options, you see these are the options. If you look at it, product C, we had shortlisted two options, product C and D. If you look at it clearly, option D is the correct answer. So I'll write the product P as well. This is the product Q, and this is the product P. This one is the product P. Okay. So here is the product P. Okay. Okay. So guys, one small information. This particular question, I would like to inform you that this question was typically from Claydon Solutions textbook. Claydon Solutions, or you can say Claydon Solution Manual. In that manual, it was specifically stated that this question is a good case where base catalyzed decarboxylation is taking place. Okay, so that's it, guys, for the first video. Please subscribe to the channel for more, and please hit the bell icon, subscribe to this channel so that you get more relevant content. I'll be coming up with detailed test series, detailed manuals, as well as tips and tricks for IIT JAM and GATE exam shortly. And see you next time. Bye bye.